Okay, I'm going to do a more challenging ICE problem this time, and this question is found on textbook page 628, and it goes to 630, so if you want to check it out there, you can as well. I first included the problem-solving strategy that the book lists, and I'll go through all the steps. So here is our problem, and it's kind of lengthy, and it'll also sound kind of familiar. This is almost identical to the problem we did on the previous video. The difference is our concentrations are a little different. So step one is always to come up with our balanced equation. It's the same as the previous one. And step two is figure out our K. Now this one is interesting because they do not give us a concentration for HF. So when we go ahead and we solve for Q, we have a 0 in the HF category because we do not have a concentration in the beginning. There was none from the start. So we already have 0 on top, and at that point you can actually stop by solving the Q because you know the overall Q will be 0 if you're doing 0 divided by anything. So if our Q is 0, then it means our K is bigger than our Q. This means our products, we're going to be going in the forward direction, products are favored, and products will have a positive sign in our in our ICE diagram. All right, I'm going to set up the ICE diagram now. Once again, we know we're going in the forward direction. Here's our equation up here. And we know that our I for each of them is 1 molarity for our H. Oh, and sorry, I did not show how to solve that, but they gave us our initial concentration for our H was 3 moles divided by 3 liters. So that's how we get the 1 molarity that I just wrote here. For the F, they gave us 6 moles in 3 liters, and so our initial concentration of our F would be 2. And our initial concentration for our HF is 0 because they didn't give us an initial concentration. Okay, so for our C, we have decided we're going in the forward reaction, so these guys get negatives, and this guy gets a positive 2x. So it's a positive x, and then a reminder, you get the 2 from the coefficient. These guys do not have coefficients, therefore they're just x. And then we're ready to set up our E, our equilibrium. So this guy would be 1 minus x. So it's initial concentration minus the change. And then our last one, there was no initial, so it's just 2x. Now we're going to plug this in. We know that K is equal to 115. And then we're going to go ahead and plug in our values. This guy on top, he needs to be squared. And then on the bottom, we get 1 minus x and 2 minus x. So as you can see, this problem's going to get a little bit more exciting because we can't just take the square root of everything like we did in our previous easier ICE problem. So we have to multiply it out, and this is going to require quite a bit of algebra, and you might have a different way that you like to do this. I'm going to show some of it. So this would be your first step, your first look at multiplying out all the factors. And next, I'm going to go ahead and multiply these guys by 115. Now, if you wanted, you can keep everything in scientific notation. That's what the book did. I just prefer to keep it out of it. Okay, so this is your next look at what we have when we've done some more algebra. And then I would recommend kind of rearranging things, make it look a little neater. And we're going to bring the 4x over here as well. Okay, so this should look like something you've seen before in your math classes, and some of you know where we're going with this. We're going to use the quadratic formula, and we know that our 111 is going to be our A, our negative 345 will be our B, and our positive 230 is going to be our C. So go ahead and plug this into the quadratic formula. And no, you may not use your graphing calculator. Please do all of your work with your non-graphing calculator. When you solve for the quadratic formula, you are going to come up with two values. They are 2.14 molarity and 0.968 molarity. And you have to decide which one would be more appropriate. So concentration cannot be negative. And so if you go back over to our original ice diagram, you'll see that the concentration of H2 is 1 minus X. So this could not be an option because 1 minus 2.14 would be a negative number. So you can cross that off. So about process elimination, we know that this is our X value. The last step you're going to do is go ahead and plug in, so 1 minus X would equal, and then you're going to do F2. The concentration in our diagram was 2 minus X, and so your answer for that is 1.032 molarity. And finally, you're going to do the HF. And the HF was 2X, and so 2 times our X is 1.936 molarity. So we're done with all the work. The last thing I'm going to do is show you how to check your work. To check your work in one of these ice diagrams is you take your initial K, and then you take your concentrations that you just determined, and you plug them in, and then you solve. And you don't have to do this, but at the same time, it's a pretty great way to see, hey, did I do this right? I mean, it is a lot of work. And when we solve this particular one, we get our answer as 113.496. And this is close enough when it comes to these. You know, there's lots of rounding and everything. So we are good to go, and we are done solving the more complex type of ice diagram.